Hi students, today we are going to look at the first chapter of the ninth class, ninth standard mathematics. Okay. This is the first lesson, first chapter, set language. A set is many that allows itself to thought as of one. Set has many, but it allows you to think it as one. George Cantor. mhm, The theory of sets was developed by German mathematician George Cantor. Today it is used in almost every branch of mathematics. In mathematics, sets are convenient because all mathematical structures can be regarded as sets. Let's see the learning outcomes. To describe and represent a set in different forms, to identify different types of sets, to understand and perform set operations and apply this in Venn diagram, to know the commutative, associative and distributive properties among sets, to understand and verify De Morgan laws, to use set language in solving life oriented word problems. Okay, let's see the introduction part first. In our daily life, we often deal with collection of objects like books, stamps, coins. Set language is a mathematical way of representing a collection of objects. Okay, let us look at the following pictures. What do they represent? Let's see the pictures first. Figure 1.1 is a set of fruits. Collection of fruits. Figure 1.2 represents a collection of household items, household objects. We observe in these cases our attention turns from one individual object to a collection of objects based on their characteristics. Any such collection is called a set. Okay. So a set is well-defined collection of objects. That is how you define set. Here, well-defined collection of objects means that given specific object, it must be possible for us to decide whether the object is an element of the given collection or not. Sorry for that. The objects of a set are called its members or elements. For example, the collection of all books in a district central library, the collection of all colors in a rainbow, the collection of prime numbers. Right. We see that in the adjacent box, in the adjacent box, right? Statements 1, 2, and 4 are well defined and therefore they are all sets. Okay, which of the following collection of natural numbers? Yeah, it is set. Collection of English alphabets, that is also set. A to Z. 4 collection of states in our country, yeah, that is also set. That is defined, clearly defined. What about 3, the collection of good students in a class, whereas 3 and 5, collection of beautiful flowers in a garden, are not well defined because they are subjective. Okay. The words good and beautiful are difficult to agree on. I might consider a student to be good and you may not. That depends on individual. I might consider the jasmine is the beautiful flower, but you may not. Mhm. So we will consider only those collections to be sets where there is no such ambiguity. Got the point? Therefore, 3 and 5 are not sets. Oh, activity 1, discuss and give as many examples of collections from diverse daily life situations which are sets and which are not sets. Okay, that you can do. Note, elements of a set are listed only once. The order of listing the elements of the set does not change the set. Okay. For example, the collection 1, 2, 3, 4, 5, 6, 7, 8, as well as the collection of 1, 3, 2, 4, 5, 6, 7, 6, 8 are the same though listed in a different order. Since it is necessary to know whether an object is an element on the set or not, we do not want to list that element many times. Notation: a set is usually denoted by capital letters of English alphabets A, B, P, Q, R, X, Y, etc. Extra, etc. The elements of a set is written with a curly brackets. They are beautiful, right? If X is an element of set A or X belongs to A, we write X set of A or X belongs to A. Okay, with this symbol. Okay. If X is not element of a set A or X does not belong to A, we will write it X does not belong to A. So with this symbol, okay. For example, consider the set A equal to 2, 3, 5, 7. Then 2 is an element of A. We write 2 belongs to A. 5 is an element of A, we write 5 belongs to A. 6 is an element of A, we write 6 is not an element of A, we write 6 doesn't belong to A. Okay. Consider the set A, Ashwin, Murali Vijay, Vijay Shankar, Badrinath. Fill in the blanks with the appropriate symbol belongs to or doesn't belong to. Okay. Murali Vijay, yeah, belongs to A. Fine. Oh, no. No, 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 no. Okay, anyway, this belongs to A. Ashwin also belongs to A. Badrinath also belongs to A. Ganguly doesn't belong to A. These are all cricketers then. Tendulkar also doesn't belong to A. Yeah, here is the solution, right? Representation of a set. The collection of odd numbers can be described in many ways. The set of odd numbers is a fine description. We understand it well. It can be written as 1, 3, 5, and so on. Also, it can be said as the collection of all numbers x where x is an odd number. Okay, all of them are equivalent and useful. For instance, the two descriptions, the collection of all solution to the equation x minus 5 equal to 3 and 8 refers to the same set. A set can be represented in any one of the following three ways or forms. Descriptive form. In a descriptive form, a set is described in words. For example, the set of all vowels in English alphabets, the set of whole numbers. Good. Set builder form or rule form. In set builder form, all the elements are described by a rule. For example, A equal to X, whereas X is a vowel in English alphabets. B equal to X. Okay, X is a whole number. The symbol colon or dash stands for such that X is a vowel in English alphabets, like that. Okay, roster form or tabular form. This is the third form. A set can be described by listing all the elements of the set. For example, A equal to A, E, I, O, U, B equal to 0, 1, 2, 3, so on. Can this form of representation be possible always? No. When the numbers or the set elements are many, you cannot represent simply in roster form. Three dots in the example 2 is called ellipsis. Okay, it indicates that the pattern of the listed elements continue in the same manner. Okay, that you might be knowing by this time. Activity 2. Write the following sets in a respective form. Descriptive form. The set of all natural numbers less than 10. Set builder form. Roster form. Okay. Roster form simply writing 1, 2, 3, 4 and so on up to 9. Okay. That is very simple. Set builder form. X less than 10 such that x belongs to n. Okay. You got the point now. Okay. You complete the table. Example 1.2. Write the set of letters of the following words in roster form. Assessment. How many different alphabets are there? You have to write it like this: x equal to A, S, E, M, N, T. Okay, whichever are repeating, you need not to write it once again, right? Similarly, principal: y equal to P, R, I, N, C, A, L. That's good. Which of the following are sets? This is exercise 1.1. Yes. The collection of prime numbers up to 100. That is set. That is set. No problem there. The collection of rich people in India. That is not a set. Okay. Oh, the collection of all rivers in India. That is a set. Right. Clearly defined. The collection of good hockey players. That is not a set. That's not clearly defined. List the set of letters of the following words in roster form. That you can easily do here. INDA. So INTA. Here also you can do that. Okay, on your own. Consider the following sets: A equal to 0, 3, 5, 8, B equal to 2, 4, 6, 10, C equal to 12, 14, 18, 20. State whether true or false. 18 belongs to C. 18 belongs to C. Yeah, correct. Second, 6 doesn't belong to A. Yeah, that is also correct. 14 doesn't belong to C. No, that is wrong. 10 belongs to B. Yes, that is correct. 5 belongs to B. 5 belongs to B. No. No, sorry. 0 belongs to B. No, not at all. Not at all. So fill in the blanks. 3 belongs to A. 14 belongs to C. 18 belongs to C. You don't know, doesn't belong to B. Okay. 4 belongs to B. Okay. Represent the following sets in roster form. A. The set of all even natural numbers less than 20. All even natural numbers means we have to start from 2. 2, 4, 6, 8, 10, 12, 14, 16, 18. That's it. Okay. B equal to y such that y equal to 1 by 2n, n belongs to n less than or equal to 5. Okay, then 1 by 2, 1 by 4, 1 by 6, 1 by 8. That's it. C equal to x such that x is a perfect cube. 27 to x belongs to 2 and 6. Oh, 27 is not involved. Okay, 3 cube 27 is not there. Perfect cube. 4 cube 64. Yes, 64 is there. 5 cube 125. So 125 is there. 6 cube 2 and 6 is not there. So there are only two elements in that set. That is nothing but 64, 64 and 125. Right. So D equal to x such that x belongs to Z. Minus 5 less than x less than or equal to 2. That means -4 -3 -2 -1 0 1 2. That is less than or equal to 2, right? That's why 2 is also included. Okay. Or represent the following sets in set builder form. The set of all cricket players in India who score double centuries in one-day internationals. Here that you can write, right? B equal to set of x such that x belongs to x is belongs to the person who scored greater than 200. Okay, greater than or equal to 200. Okay, C equal to 1 by 2, 2 by 3, 3 by 4. N by n plus 1, where n belongs to all natural number. Okay, that's how you can define C. Okay, n by n plus 1, where n belongs to capital N, or x by x plus 1, where x belongs to n is natural number. The set of all Tamil months in a year, that also you can form. Okay, fifth one also, fourth one also you can form. Represent the following sets in descriptive form. P is January, June, July. Now what is descriptive form, by the way? Go back once. Descriptive form. Set is described in words. Okay, right. Now we will describe that in words. January, June, July. What is common among them? January, February. Yes, January, February, March, April, May, June, July. Oh. See, all these months start with the letter alphabet J. January, February, March, April, May, June, July, August, September, October, November, December. Oh, there are no other months which start from J. So P belongs to P is a set of X such that X starts with A. Oh, that is not descriptive form, right? Descriptive form means P is a uh, uh, set of months which start with the letter J. Okay, that's how you can write. What about Q? 7, 11, 13, 17, 19, 23, 29. What are all these? These are all prime numbers. Prime numbers uh, greater than 5 and less than 31. Okay. So Q is a set of all prime numbers which are greater than 5 and less than 31. Okay. R is x belongs to n, x less than 5. What does R has? 1, 2, 3, 4 only. 1, 2, 3, 4. Okay. R is set of first 4 natural numbers. In that way also you can write, no problem. Okay. Fair enough. Your last one you can do on your own. Types of sets. There is a very special set of great interest. The empty collection. Why should one care about the empty collection? Consider the set of solution to the equation x square plus 1 equal to 0. It has no elements at all in the set of real numbers. Also consider all the rectangles with one angle greater than 90 degrees. There is no such rectangle and hence this describes an empty set. So the empty set is important, interesting and deserves a special symbol to write. Empty set or null set. A set consisting of no element is called empty set or null set or void set and defined by denoted by phi or this empty symbol. Okay. Or the sets 0 and 5 empty sets. This has 0 in it. This has empty set in it. For example, a equal to x is an odd integer and divisible by 2. That is empty set. The set of all integers between 1 and 2. That is also empty set. Singleton set. A set which has only one element is called singleton set. X such that 3 less than x less than 5, x belongs to n. There is only one element, that is 4. The set of all even prime numbers, that is only 2. Okay. That is singleton set. Finite set. A set with finite numbers of elements called finite set. Empty set has no elements, so phi is a finite set. For example, the set of family members, the set of indoor outdoor games you play, the set of curricular subjects you learn in your school, A equal to x such that x is a factor of 36. Infinite set. A set which is not finite is called infinite set. Is there a set of natural numbers is a finite set? No. No. It will go on, go on, go on, go on, right? So not a finite set. For example, 5, 10, 15 and so on. The set of all points on a line. To discuss further about the types of sets, we need to know the cardinality of sets. What is this cardinality of sets? The number of elements in a set or other grouping as a property of that grouping. Okay. Cardinal number of set. When a set is finite, it is very useful to know how many elements it has. The number of elements in a set is called the cardinal number of the set. The cardinal number of set A is denoted by n of A. Oh, the number of elements in a set is nothing but its cardinality. Okay. Right. If A is this, find n of A 1, 2, 3, 4, 5, 6, 7, 8, 8. Okay. Here you go. Thinking corner. Then n of A is what? 1, 2, 3, 4, 5, 6, 7, 7. Equivalent sets. Two finite sets A and B are said to be equivalent if they contain the same number of elements. It is written by A equal to B. If A and B are equivalent sets, then n of A equal to n of B. For example, consider A ball bat and B history geography. Same number of elements, that's it. Here A is equivalent to B, hence n of A equal to n of B equal to. If let A, X is a color in a national flag of India, and B red, blue, green. Are these two sets sets equivalent? Yeah, numbers are 3 in A also. Here also number is 3, so they are equivalent. Okay. P is this so, and Q is set of all prime factors of 2, 10. Equivalent sets. First you do this -3, -2, -1, 0. Okay, prime factors of 2, 10. 2, 3, 5, 7. Yeah, this is 4, that is 4, so equivalent sets. Okay, we'll stop it here at the equal sets. We'll continue the remaining in the next session. Okay, thank you. Nandri Vanakkam. See how beautiful this nature is. You also start planting the trees. Let us bring a new change in our society. Let us plant the trees and let others plant the trees. Let's take this pledge seriously from now. Thank you.